Lesson 2.4 is on factoring quadratics. We have talked about grouping and using the box method to factor, and it works when we have a quadratic that has 4 terms. Okay, and if you look here at number 4, it's 6a squared minus 5a minus 6. The issue with this guy is that he only has 3 terms. So we need to figure out how can I make him into a 4-term polynomial. And the way that we were doing this in class is that we expand the middle term. Okay, we blow up the middle guy to be 2 terms, that when I combine them back together, I still get negative 5a. So the way that we did this is we did have a little bit of a process to follow here. We need to first ask if there is a greatest common factor. 6, 5, and 6. They're relatively prime to each other. Okay, the 5 doesn't share anything that the 6's do, and they don't all have an a. So unfortunately, there's nothing I can pull out to make it smaller. So what I need to do is I need to identify my a, b, and c values. So here's a, here's b, and here is c. Okay, make sure that the negatives stay with the numbers. So when I multiply a times c together, it's 6 times a negative 6. So I end up with negative 36. And the question is, what are factors of negative 36 that add up to be negative 5? Well, I can always check the factors that I started with, 6 and negative 6. But if I add those up, they add up to 0. So that doesn't work. How about maybe 1 and negative 36? Well, it's negative 35. Negative 1 and 36? Nope, that's positive 35. So you just have to keep going down. You can go through 2, you can go through 3, and you keep going until you find one that works. I'm going to try 4 and negative 9. Okay, 4 times negative 9 is negative 36. And when I add them together, I do get negative 5. So this is actually the magic pair right here. Okay, so what I'm going to do is rewrite this guy. And I end up with 6a squared. You can put the 4 or the 9 first, it doesn't matter. Let's do the 4a minus 9a, and then minus 6. So the only thing I did, actually let me do this, move this over here. The only thing I did is I split up the negative 5a to be 4a minus 9a. If I put them back together, I still have negative 5a's. I just uncombined like terms. Notice now that I have 4 terms, and I can do my factor by grouping or my box. So for this problem, I'm going to do the grouping. Okay. Notice that they share a 2 and an a. So that leaves 3a plus 2. And then this guy, I know I need to pull the negative out. 9 and 6 share a 3. That leaves me with 3a, which is good because it needs to match this guy. And I changed the sign on the 6 when I pulled the negative out, and then pull a 3 out plus 2. So notice that my leftovers match now, okay, which is good. And so what does that say? It says that I take 2a and I distribute it to the leftovers, 3a plus 2. And then I also take a negative 3 and distribute it. And that's what my answer should be, okay? Before I put a box around it, though, I want to just double check, are these relatively prime to each other? 2 and 3, yes. Okay, they don't share a's. Are these relatively prime to each other? And the answer is yes as well. So the only thing I need to do now, in order to actually finish out my homework, is to check my answer. And that just requires me to go back and FOIL or use the box. So I'm going to use the box just because it's very visual here. And it looks like I get 6a squared minus 9a, 4a, negative 6. When I pull it out of the box, I get 6a squared. These guys are like terms, minus 5a when I put them together, minus 6. And when I check back up here, that is exactly what I started with. So my answer is indeed these two factors were multiplied together to get the problem that they presented me with. Okay, and that's all you have to do for that guy.